everyone, welcome back to my YouTube channel. In this video, we shall learn about partial pressure by using Dalton's law. So let's get started. A mixture of gases contains 4 grams of hydrogen, 44 grams of carbon dioxide and 28 grams of nitrogen. The mixture is kept in 10-liter container at a temperature of 300 Kelvin. Given that the atomic mass of hydrogen, carbon, oxygen and nitrogen are 1.0078, 12.011, 15.999 and 14.067 respectively. Determine the partial pressure for nitrogen. In order for you to answer this question, the first thing that you need to do is you need to calculate the number of mole of each item. So we are going to start with the number of mole of hydrogen. So since this is a hydrogen gas, so the number of mole for hydrogen gas shall be equivalent to mass, which is 4 grams, divided by the RMM. So the hydrogen is 1.0078. Since it's an hydrogen gas, you need to times 2. Therefore, you will get 1.9845 mole of hydrogen. Right. So we are going to do the same with the rest of the thing, which is carbon dioxide and also nitrogen. So we are going to start with carbon dioxide. So number of mole for carbon dioxide should be equivalent to 44 grams divided by the carbon dioxide. So carbon is equivalent to 12.011 plus CO2. So 2 times your oxygen. So oxygen is 15.999. Therefore, you will get the number of mole for carbon dioxide is equivalent to 44 divided by 44.009, which should be equivalent to 0.9998 mole. And lastly, we are going to calculate for nitrogen. So number of mole for nitrogen shall be equivalent to the mass is 28 gram divided by this one. So 14.0067 times 2. So it should be equivalent to 0.9995 mole of nitrogen. Alright, so next up we need to find what is the total number of mole. So the total number of mole is equivalent to the summation of 3 of this. So you will have 1.9845 for the hydrogen plus 0.9998 for the carbon dioxide plus 0.9995 for the nitrogen. Therefore, the total number of moles should be equivalent to 3.9838 mole. Alright, so next up, what we are going to do is we are going to use the ideal gas law, because in the question, you were asked to determine the partial pressure of nitrogen. So basically, in ideal gas law, the formula is PV is equivalent to nRT. So what is the partial pressure for nitrogen, right? So we need to find what is the pressure first. So the pressure should be P is the one that you want to calculate at the moment, and V, so in the question it states that it is being kept at 10-liter container. So V is 10 liter. N, so what is N? So the N should be the total number of mole. So the total number of mole is equivalent to 3.9838, right? And R is the gas constant, which is 0.0821. So I'm going to write this one. The N is mole. So this one, the unit is liter, atmosphere over mole Kelvin, right? And then your T, what is the temperature given in the question, is 300 Kelvin. All right, so from here, what we can calculate is, we can calculate what is the P. So before I do that, I'm just going to show you what shall be the final unit be like. So for here, you can slash out your K. So here is mole, so mole, slash out the mole as well. And then you have liter, liter here. When we rearrange this, liter will be slashed out as well. And you should end up with having the unit for pressure should be in ATM. So basically, when you just plug this in your calculator, you just have to write 3.9838 times 0.0821 times 300, and then you need to divide it with 10, so you will get your P is actually equivalent to 9.8121 ATM. Right, so this shall be considered as your total pressure, because you're using the number of mole for all of the gases. Alright, in the question, you were asked to calculate what is the partial pressure for nitrogen. So in order for you to find what is the partial pressure, the first thing that you need to do is you need to calculate the mole fraction. So the mole fraction for nitrogen is equivalent to the number of mole of nitrogen, 0.9995 mole, divided by the total number of mole, which we have calculated before, 3.9838 mole. So this one you can slash them out. So you will get the mole fraction for nitrogen is equivalent to 0.25089. So this is the mole fraction. But in the question, you were asked to calculate what is the partial pressure. So therefore, the partial pressure for nitrogen is equivalent to total pressure times mole fraction. So the total pressure is 9.8121 atm. So times the mole fraction, which is 0.25089. Therefore, you will get the partial pressure for nitrogen gas should be equivalent to 2.4618 atm. So this is the final answer for this question. Thank you very much for watching this video from the beginning till the end. So I'll see you again in the next video. Goodbye.